Okay, this is our new rotary screw range. The bottom of the range is the Silver 10, which is a 10 horsepower rotary screw compressor on a 300 litre receiver. Inside the rotary screw we have what's called an encapsulated screw end, which means the oil tank and the air end are one piece. We have a oil separator, an oil filter which we'll zoom in a minute and have a look up close, the oil tank with a sight gauge, electric motor, a couple of V-belts to drive the air end, and an adjustable pulley tray on the bottom here to set the tension on the belts. When the rotary screw runs, what happens is in the air end there's two opposing screws that are very tightly machined to one another. In fact, I think it's 0.04 millimetre is the gap between the two of them. As they turn, they force the air down the screw end and into the tank. The pressure of this machine operates between 8 and 10 bar, and if we come in now I'll show you some of the components up close. Okay, we've got a 10 horsepower or 7.5 kilowatt electric motor tucked in the back here. This is a class 1 energy efficiency motor, so it conforms to the new MEPS standards in Australia. We've got a dual V-belt, and it's very important when you commission these compressors that the electric motor is running in the right direction. There's a large red arrow on the outside case of the cabinet of the compressor that shows the right direction. So when you wire it up with the 3-phase plug, it's a quick on-off just to check that it's running the right direction, because if it runs for more than 5 seconds in the wrong direction, you can damage the air end. The air end, as I mentioned before, has two opposing screws in it that are very tightly machined together, and the oil actually forms like a piston ring, if you like. It seals between the two air ends, so as the air is forced it can't go backwards. It's like a gasket. We have an air filter on top, which is just like any normal air filter on any compressor or on a motor vehicle. It's got a filter cartridge inside it that needs to be replaced or cleaned out when servicing. We've got an oil separator. This is what happens when the air comes out of the screw end. It contains a mixture of the oil and air. And what we want to do is get the oil out of the air and back into the oil tank. Behind the air separator, there's another oil filter, which is very similar to an oil filter on a car. Both the separator and the oil filter, when they're replaced, are just unscrewed and a new one fitted on. So when the air is compressed in the screw end, it passes out of this hose here, round the back, externally past the radiator and then down into the tank. The oil comes out of the tank through the radiator, then back through the oil filter at the back, then into the screw end. When the compressor first starts, it goes through 3 stages of compression. The first stage, it just builds up enough pressure to pressurise the oil in the tank so that the oil is forced up into the screw end to lubricate it. Then when that's done, it goes through a next stage, which is a transition stage, and when it builds up to a little higher pressure, it opens a valve on the air intake that then allows full air intake so as the air can be compressed into the tank. When we start the compressor in a minute, you'll hear the difference in the 3 stages. So here's the control panel, on-off button. In the field here we'll see the oil temperature, so let's start her up. Oil temperature current 40. If we listen for the phases now, 2, 3. So now it's pumping air. Temperature rises very quickly on the silver machines, within 2 minutes to 70, 75 degrees Celsius. So this avoids a lot of condensation in the water by taking a long time to heat up. When the compressor reaches 10 bar, it stops, as it's just done now. The air intake's closed. So you can see on the gauge here, the pressure in the air end is decreasing. It's depressurizing the air end, whereas the pressure on the gauge on the end in the tank, which shows the tank pressure, is set at 10 bar. So now the air pressure is decreasing in the air end, and this will continue to wind down for 2 minutes. When it's empty, the machine will stop until the air supply is needed again. One of the features of the FIAC machine over Atlas Copco models and some of our other competitors, if you turn it off, it doesn't stop immediately. It continues to run until the air pressure in the air end is down, and then it'll stop. This is a good feature because the air end cannot be damaged when restarting again. Okay, one very important feature of rotary screw machines, these FIAC machines, is when they're first turned on. It's very important, as I mentioned, that the belts inside are running in the right direction. So when you wire it up with the 3-pin plug, it's best to you can see here there's a big red arrow that shows the direction that the motor should be rotating. So what you do is you wire up, when you first turn it on, you just turn it on and off, on and off. And as you do, you just quickly look that yes, it's rotating in the right direction. If it's running in the wrong direction, you have to rewire the plug to get the two active terminals round the other way, then it'll run correctly. Just check again, yes, it's running in the right direction, everything's fine. Okay, this is the 20 horsepower model, or CRS models. The internal workings are the same as on the silver. It's an encapsulated air end again, which means the oil tank and the air end are in one piece. Oil fill, oil drain. A couple of differences with the CRS models. They're a little bit more upmarket. You don't have to adjust the belt tension manually. As you can see, the weight of the encapsulated air end sits on a spring counterlever, which as the weight of the machine against these springs just keeps the correct tension on the belts. Another noticeable difference is on the silver models, the air before it goes into the tank just passes externally around the radiator. On the CRS models, the radiator is on the top of the machine, so it gets rid of the hot air, and the air actually passes internally through the radiator. So the cooling of the air is better on the CRS models than the silver. Of course, the oil goes through the radiator as well, and we also put the CRS models on the 500 litre tank. The control panel on the CRS models is a little bit more sophisticated than on the silver machines. It has a calendar in there which has the full history of the machine in terms of if there's been any alarms, when and where they occurred. So it's very good for the maintenance guys to look back, if need be, on the history of the machine. There's also a calendar in it, so you can program the start time and the stop times and you know, holiday days and all sorts of things, so that no one has to come and turn it on and off. It'll just work off the calendar. Also, it has many language settings and other features like that. We offer the new silver models and the CRS models both with a dryer, fully incorporated into the machines. The dryers on the new silver model do not have pre and post filters on them, whereas the dryers on the CRS have pre and post filters of them. This is just a cost because the CRS is a higher quality unit. The dryer is basically a refrigerator. It takes the hot air out of the tank, it passes it through a refrigerated chamber, it centrifuges it, the condensate goes to the outside of the centrifuge, and the warm air is sucked up from the middle of the centrifuge and then pumped out down the line, completely free of any contaminants or oil or water. As you just heard, it has a solenoid valve that kicks in that releases all of the filtered contaminants onto the base of the machine. That filter kicks in about every 2 minutes to discharge it, and it's automatically operated. There is some adjustments in terms of setting the temperature and dew point, but I don't think for our customer base, because our climate in Australia is pretty mild in comparison to many countries, there's no need to reset it. It runs off 240 volt 10 amp plug. It's on a separate circuit to the compressor.